Hello everyone, welcome to Mam and Me Academy. I'm your mathematics educator Bipul Babu. Today let us start a very new chapter which is probability, and it is the 15th chapter from your book. Now let us try to understand the word probability. Can you find a word which is hidden in this topic, which is probably? There is a word probably hidden in this word probability. Now what is the meaning of probably? You might have used this word in your daily life that probably it might rain tomorrow. That means there are chances of raining tomorrow. Okay, you are not sure whether it would rain or not. So we can say that probability means the chances. What are the chances for an event to occur, right? In this chapter, we will deal with the probability or the chances with a numerical approach. That means we will use a numerical approach to this chapter or this word chance. Now how to find the probability? See, there is a very simple formula which you have studied from your earlier classes, that probability equals number of favorable outcome. Okay, number of favorable outcomes upon total number of outcomes. Total number of outcome. Now what is favorable outcome and the word outcome? Let us discuss that also. If I give you a certain situation that toss a coin, okay, toss a coin, you might get a head, okay, or a tail, right? If I ask you to toss a coin, you might get a head or a tail. This head or tail is known as the outcome. What is that? Outcome. It is the outcome. Now what is favorable outcome? Favorable outcome is the question asked. For example, I may ask you how many times you will get head. That means our favorable outcome would be head. Let us take another example. Let us roll a dice. Let us roll a dice. Okay, I'm rolling a dice. What numbers can you get? You can get either 1 or 2 or 3 or 5 or 5 or 6. Sorry. Okay, so you can get 1, 2, 3, 4, 5 or 6. So this is known as the outcome when a dice is rolled. Now what about the favorable outcome? It depends upon the question. For example, I may ask you, what is the probability, okay, what is the probability of an even number, So when you'll throw the dice, what are the even numbers here? 2, 4 and 6. So this will be your favorable outcome, right? Favorable outcome. Let me just sum it up. What is probability? Probability means chances. Now here in this chapter, we will associate a number to the chances. How to find the probability? The formula is very simple. Probability is equals to number of favorable outcome upon the total number of outcome. Then I told you what is outcome. Outcome is the result of an event, right? What is that? If you throw a coin or if you toss a coin, you might get a head or a tail, which is the outcome here. Now if you roll a dice, you might get 1, 2, 3, 4, 5 or 6, one at a time, right? So these are the outcomes when you will throw a dice. And what is the favorable outcome? It depends upon the question. What is asked in the question will be your favorable outcome. Now let us see what all things are there in the probability and what is the characteristics of the probability. Now let us see some more information on probability. As you can see the formula here, probability equals to the number of favorable outcome upon the total number of favorable outcome. Now you can see from the formula that the word probability depends upon the number. See, In the denominator also there is a word number here. That means probability is depending upon number. We have to count the outcomes, right? Can you count the outcomes in negatives? Can you, or do you count like this, -1, -2, -3 and so on? No, you count like 1, 2, 3 and so on. That means you will never get a negative value here and a negative value here. Okay, since you cannot get negative values in the numerator and the denominator, that means probability is purely positive, right? So the first point which you get is that probability can never be negative. Okay, it cannot be negative because we don't count in negatives. We use the natural numbers for counting, or the whole numbers for counting. Now, can the favorable outcome, the number of favorable outcome, be greater than the total number of outcome? Let us understand this way. If I ask you to roll the dice, then how many outcomes will you get? You will get 6 outcomes, right? 6 outcomes. Can you get 7 outcomes out of that? No, right? That means your favorable outcome can be either equal to 6 or less than 6. You can get the 6 favorable outcomes or less than that. You cannot get the favorable outcomes greater than 6, right? Or in case of the coin, if you toss a coin, you will get head or tail. That means there are 2 outcomes. The favorable outcome can be equal to 2 or less than 2. It cannot be 3 or more, right? That means the numerator is smaller than the denominator. Are you getting to my point? The numerator is smaller than the denominator, which implies that probability of an event, okay, probability of an event can never be greater than 1. Okay, this is a very important point. What is this? Probability of an event can never be greater than 1. Okay, you will not get the probability as 1.2, 1.3 or so on. Okay, so let us try to combine the first and the second sentence. The first sentence is that probability can never be negative, right? From the first statement, we can conclude that the probability of an event, let us denote this as PE. What is it read as? It is read as probability of an event, E. Okay, probability of an event E can never be negative. That means it is always positive. Okay, it is always positive. So we use the sign greater than 0 for positive values. And the second statement can be written as PE, the probability of an event, can never be greater than 1. Okay, this much is clear to you? Now, can the probability of an event be 0? Can it be possible? Yes. See how? If I ask you that throw a dice, you will get 6 outcomes. Okay, and if I ask you that what is the probability of getting 7 when I throw a dice, then what will be your answer? You might say that, sir, there is no 7 on the dice, right? That means your favorable outcome will be 0 and the probability in turn will be 0. That means the probability of an event can be 0. Okay, it can be 0, but it cannot be less than 0. Okay, now if I throw a dice once again, then I ask you a question that you will get a number. Obviously, if I throw a dice, you will get a number. Either it be 1, 2, 3, 4, 5 or 6. All are numbers. That means the probability can be equal to 1. Let me repeat. The probability of an event can be 0. Example, if I ask you to throw a dice, and then if I ask you a question that what is the probability of getting 7, or what is the probability of getting 8, you won't get 8 or 7 while throwing the dice, because there is no 7 or 8 on the dice, right? So the probability will be 0 here. Now if I ask you what is the probability of getting a number while throwing a dice, it will be 1 only, because all the 6 are numbers only. So here 6 upon 6 will be equal to 1. The probability will be equal to 1. Now let us combine these two statements also. So you can write it as the probability of an event E is always greater than or equal to 0 but less than or equal to 1. Okay, this is a very important conclusion that we have drawn, that probability of an event is always greater than or equal to 1, or it is equal to 1 or less than 1. Now let us see some basic definitions related to probability depending upon the outcomes. Okay, now let us see some definitions. Okay, these are very basic definitions. The first definition is sure event, or you can say certain event. Now as the name suggests, sure event, that is the event which is certainly going to happen. For example, if I throw a dice, I have already discussed this example, right? So let us take another example. If I throw a coin, okay, what is the probability of getting a head or tail? It is 1, right? It will happen, either head will come or tail will come. Okay, if you are not able to understand this example, let us take another example. Okay, if I take a sack, okay, if I take a sack, this is the sack, let us consider this as a sack. Now I am putting some red balls into it. There are 5 red balls here. Okay, now randomly, without looking at it, I am taking a ball out of the sack. Now what is the probability that I will get a red ball? What is the probability? It is sure, because all the balls are red. Okay, so what is sure? Sure event? The event whose probability is equals to 1. So I am writing it here, the definition. The event whose probability is equal to 1. Okay, if you get an answer equal to 1, that means that event is sure to happen, just in this case. Now if you are not able to understand what is the sure event, let me explain it further. Let me put 2 more balls which are white in color. Okay, now I have shuffled them. Okay, now I'm taking out a ball out of the sack without seeing, okay, at random. Then can you tell me whether it is red or white? Can you tell? No, because there is a mixture of 2 balls, red and the white. So you cannot tell for sure that it will be white or red. That means this is not a sure event. Now if I remove these 2 white balls here, okay, if I remove these 2 balls and then if I draw a ball out of this, then it will be sure that it is a red ball. Okay, so this is a sure event. Now another event is impossible event. Impossible event. See, it is very simple because the word itself explains everything. Okay, now what is impossible event? If I consider this case only, if I draw a ball out of it and ask you what is the probability of getting a black ball, you will say that there are no black balls inside it. How can you draw a black ball, right? That means impossible event are those events whose probability is 0. So the event whose probability is equal to 0 is known as impossible event. Now I will be discussing some situations in which how to find the total outcomes of that situation. We will see the throwing of coins, throwing of dice, okay, and the cards. So let us see the next clip. Now let us see how to find the number of outcomes. In this case, we are seeing the outcomes for a coin. The first is when we throw a coin, that means we are throwing one coin. When you throw a coin, you can either get head or a tail. Okay, so the outcomes are, I'm writing the outcome here, head, comma, tail. If number of outcome is asked, that means there are two. What is this? Number of outcomes. There are two outcomes, head or tail. Now let us increase the number of coins. Now I am throwing two coins, or it can be said I am throwing a coin twice, okay, two times. Then when I throw it for the first time, a head can appear. A head can appear. And then I throw it for the next time or the second time, I can get either head or tail. Okay, try to understand this. If I throw the coin for the first time, okay, let us consider two coins here. These are two coins. If I throw the first coin, I may get the head first, okay, and then I am throwing the second coin, then I can get the head. Okay, this is just a probability, a chance. Or it might happen that I am getting the head in the first throw but a tail in the second throw. So this way we can write it in the here like a tree form, that in the first throw we can get either head, and then in the second throw we can get head or tail. Okay, so this is one case. Now the second case is that we can get the tail in the first throw. Okay, we can get the tail in the first throw. Then when I'll throw the second time, I might get a head or I might get a tail. So how to write here? If in the first throw we get a tail, we can get a head in the second throw. We can get, okay, I'm not saying it for sure. We can get the head in the second throw or the tail in the second throw. Now let us write the outcomes here. So the outcomes are head, head, okay, head, head. This is your first outcome. Second, head, tail. That means head on the first coin and tail on the second coin, comma, tail, head, TH, and tail, tail. Okay, if you are not able to understand this way, this is a very simple way of understanding. See, head, 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 tail, tail, head, tail, tail. All possible combination which you can make with two coins. Okay, now the total number of outcome is how many? 4. Okay, 1, 2, 3, 4. Now let us see that we are throwing 3 coins. Okay, now in this case we are throwing 3 coins, and it can be rewritten as if I am throwing a coin 3 times. Okay, you can find this statement that if 3 coins are thrown or the coin is thrown 3 times, it is both same. Okay, now in the first throw I might get head, then in the second throw I might get head or tail. Simple. In the first throw, this is the first throw, okay, in the first throw I can get a head, in the second throw I can get the head or the tail. Now I have to toss it again for the third time, then I can get head or tail, right? Similarly here, head or tail. Now if I get the tail in the first throw, then I can get the head or tail in the second throw. Similarly, head or tail in the third row. So the outcomes are, let us write the outcomes here, H H H, okay, triple H, comma, H H T, comma, H T H, comma, H T T, then T H H, T H T, T T H, T T T, triple T. So how many outcomes do you get? Did you get 1, 2, 3, 4, 5, 6, 7, 8? The total number of outcomes is 8. Did you understand? This much is there in your syllabus. They won't ask you for the 4 coins. If they ask you, you can find this in this way. Okay. Now let us try to summarize it with a formula. Okay. The total number of outcomes with a formula. Just note it down in your copy because it's very important. Okay, I'm discussing this with you so that it would be easier for you to solve the exercises. Okay, now let us see a formula based on this concept. Now let us try to derive a formula for finding out the number of outcomes when a coin is thrown. Okay, do remember I'm talking about the coin. See, in the first case, when I threw the coin one time, okay, let this be denoted by n. What is the n here? The number of times a coin is thrown. What is n here? The number of times a coin is thrown. In the first case, let us write it here. In the first case, the value of n was 1. Okay, the value of n was 1 and the total number of outcomes was 2. Okay. Second, in the second case, we threw 2 coins or a coin 2 times. So the value of n will be 2 here and the number of outcomes would be 4. Right? Then in the third case, we threw 3 coins, right? Here it was written here, no? So the value of n will be 3 and the number of outcome was 8. Now can you derive a formula for this? See, this is for 1 it is 2, for 2 it is 4, for 3 it is 8. See, this you can see that it's the power of 2. See, this is 2 to the power 1, 2 to the power 2, 2 raised to the power 8, right? So in general, we can say that in general, the number of outcomes or total number of outcomes, it would be better to write total number of outcomes when a coin is thrown n times, okay, is equals to 2 to the power n. See, you can check by yourself. If I throw the coin twice, so it will be 2 to the power 2, that means 4. If I throw the coin 3 times, it will be 2 to the power 3, which is 8. Simple. Now let us see the finding of outcomes for a dice. Okay, now let us see how to find the number of outcomes for a dice. In the first case, when a dice or a die is thrown, see, somewhere in the question you might find the word dice, or in some questions you might find the word die. It is same. Okay, so when a dice is thrown once, okay, when a dice is thrown once, see, what are the possible outcomes? It can be, the outcomes are 1, 2, 3, 4, 5 and 6. These are the possible outcomes, right? What is the total number of outcome here? It will be 6. So this is very simple. Now let us see the second case when two dice are thrown. Okay, it can be written as when two dice are thrown or when a dice is thrown twice. Do notice, when two dice are thrown or when a dice is thrown twice. So it can be, the outcomes are, let me write it here, the outcomes can be, see, when you throw a dice for the first time, you might get 1. Okay, and then you will throw it for the second time, you can get 1. Or if you get 1 here in the first throw, you might get second in the second throw. Okay, and if you get a 1 on the first throw, you will get 3 on the second throw. Okay, similarly, if I continue to write like this, you might get these outcomes. Okay, 1 1 1 2 1 3 1 4 1 5 1 6. Okay, now for the first throw, if I get 2 as the outcome, then I can get 1 as the second outcome, 2 comma 2. Okay, now I think you have understood the pattern. 2 2 2 3 2 4 2 5 2 6. Similarly, for the 3 1 3 2 3 3 3 4 3 5 and 3 6. Then 4 1, right, 4 2 4 3 4 4 4 5 4 6, 5 1, so on up to 5 6, 6 1, so on up to 6 6. So you can see that the number of outcomes here will be, if you count it, you will get 36. Okay, you will get 36. When the dice is thrown for a one time or once, you will get the outcomes as 6, and when the die is thrown twice, you will get the outcome as 36. Now let us try to derive a relation for this also. See, this is the power of 6. As in the case of coin, you got the power of 2. Here you are getting the power of 6, right? So in general, we can say that this is the formula. I am writing it here. Okay, this is the formula. In general, when a dice is thrown n times, okay, n times, then the total number of outcome would be, total number of outcome would be 6 to the power n. Check it for yourself. When the dice is thrown for once, the value of n will be 1. That means 6 to the power 1, which is 6. Okay, when the dice is thrown twice or 2 dice are thrown, the value of n will be 2. So 6 to the power 2 will be 36. Okay, this much can be asked in your syllabus. It won't ask you for the 3 dices. Okay, this is there in the 11th standard. Now let us study about the last topic of this video, which is the cards. Okay, the cards which you used to play. Okay, so let us clear this and then see the topic. Now let us talk about the cards. Okay, these are those cards which you used to play. Okay, now there are 4 sets of cards in the packet. Okay, in the pack you will get 4 sets of the cards. Now what are they? Let us try to decode it, or let us try to understand it in deep. See, the 4 sets are spades, club, diamonds, heart. These are the 4 sets of the cards in the pack. Okay, now as you can see that I have shaded it. See, the spade is in the black color, club is in the black color, diamonds in the red color, and the heart in the red color. Okay, now Let us see what all cards are included in the spades. In the cards, there is no card numbering 1. Okay, there are no cards associated with 1. Instead, we use A. Okay, this is known as ace. This is known as ace card. Then 2, 3, 4, 5, 6, 7, 8, 9 and then 10. Okay, the other cards remaining are king, queen and the jack. Okay, similarly the same type of cards are there in the other sets as well. Ace, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Then king, queen and jack. Here also ace, 2, 3, 4, 5, 6, 7, 8, 9 and 10. King, queen and jack. Okay, I'm not writing it for the heart because it is all same. Now there is a speciality to each card. Okay, in this card you will see that a card is like this. I hope you might have seen it. Okay, A will be written here, something like, or the number will be written here. Okay, this is an ace card and the other are number cards. King, queen and jack, these are very special cards because they have a face in it, right? If you haven't seen it, just try to see it. Okay, just Google it, or if you have the cards, you can see it. That king, queen and jack have the faces on them, so they are known as the face cards. They are known as the face cards. Okay, these are the face cards. The other cards are not face cards. So in all, let us count the number of cards. In the spades there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means there are 13 cards of spade, 13 cards of club, 13 cards of diamonds and 13 cards of heart. In all, there are 13, 13, 13, 13. That means 13 fours are 52. In all, there are 52 cards. Okay, do note in your notebook. This is very important. I think no one would tell you this in such deep. Okay, see, 13 fours are 52. That means total cards are 52. Okay, now let us draw the conclusions. Okay, what all things we should know about the cards. I'm rubbing it. Okay, now let us write some theory related to this, related to the cards. Okay, now total number of cards. Total number of cards. How many cards are there? 52. 52. Now if I ask you about total number of black cards. Black cards. These are 13 plus 13, 26. Right. Now total number of red cards. These are 26. 13 plus 13. Now I use the word face card, right? Total number of face card. It was, see, in each set there were 3 face cards: king, queen and the jack, right? So 3 in this, 3 in this, 3 in this and 3 in this. 3 fours are 12. There are 12 face cards, out of which 6 are black in color and 6 are red in color. Okay, now total number of ace cards. Total number of ace cards. There are 4 ace cards because there are 1 in each set. 1 plus 1 plus 1 plus 1, it is 4. Okay, I hope you have understood this much. Now we'll meet you in the next video with the examples of this chapter. I hope you have understood this topic very clearly. If you have any doubts, you can ask us on the mail given here or in the comment section below. Till then, be happy, be safe and study with Ma'am and Me Academy.